Okay, so now let's go to the second question, the behavior, the unsupervised learning question. Unsupervised learning, you have this data set, okay? Just let us say there is no division of predictor and response, just data set. Let's say height, weight, hair color, okay? Now your goal is to, so when you plot the data set on 2D, in 2D, let's say, you find these clusters out there. For example, if you take height and weight, or if you take the height and hair color, you will see that this cluster is, there are few clusters out here, okay? It's in 2D, let's say two predictors are there. This x-axis is one predictor, let's say height, and this y-axis is hair color, let's say. I mean, it's not numerical, but let's say weight. So you can see that this group above, you can see the 4 groups. Maybe the first group is above from Africa. Sorry, it's like less height and more weight. I mean, just let's assume, okay, let's not go into like the details of whether it's true or not, but let's say this is Africa, this is Australia, this is like America, this is India, okay? Let's take an example. Like 4 clusters correspond to different continents. So this is what I mean by behavior. That how do this number of x, like how do these variables predicted, like x variables, behave together to form similar similar clusters? That's one type of understanding, like behavior, like together how they are behaving. Okay, that's the goal. And this is one for clustering, and forming this cluster of similar behavior is essentially one of them. There are more different styles. So for people of mathematically and statistically oriented people who have done it, unsupervised learning is like, if they know the linguistic. If you don't understand, don't panic, okay? It's just for them. Because I want to cover the entire spectrum of people. Unsupervised learning is nothing but estimating the distribution of the variables, joint distribution. And supervised learning is like joint distribution of x, okay? Estimating the density and the density of the joint distribution of x, or the PMF. Finding an approximate density. And supervised learning is nothing but finding an approximate conditional distribution of y given like the response given the predictors. Okay, these are the two difference, nothing else. In a statistical way. Okay. So your goal is to find these clusters. Okay. Now let me show some examples to you. Supervised learning example is this. So if you can see this example, I hope all of you can see it. If not, please zoom in. So you can see on the this class identifies a wine data set, and in this wine there are like various in the the predictor set, there are a lot of chemicals out there: alcohol, malic acid, ash, alkalinity of ash, magnesium, total phenol, flavonoids, non-flavonoid phenols, cyanins, color intensity, hue, dilated one, whatever it is, proline. These are predictors. And why is the class identified? It's telling you like this wine is class identifier 1, probably 1 identifies to a specific wine, 2 identifies to another wine. So I mean, I didn't show the entire data set, so just it's all 1 on the Y. So there are number of 3 different wines. So the goal is to find out, like, if I give you a new alcohol, new malic acid, new ash, and all these things, what will be the wine type? That's the question. Okay. And therefore, your goal is to predict the wine type from the chemical composition. This is a supervised learning. Now, for unsupervised learning, you will just remove the wine type thing. Okay. It will become an unsupervised problem. Because now you will find out which wines are actually behaving together. Okay. We don't know the wine names. It's like you see multiple cat pictures and see that they're familiar, but you are a kid, you see that there are a lot of cats. You see that they're similar, but you don't know they're a cat. Okay, but you know they're a similar group. You understand? So the extra addition that, okay, this is a predictors of cat law. When you're seeing a lot of cats together, you see whiskers, you see fluffiness, or whatever, the tails, short body, you see all these features out there. These are features, but you don't know the name. That's a cat. So if someone asks you, hey, can you show me your cat? I'm showing you this. Tell me what this animal is. That person will never be able to tell. But that person is able to understand that, okay, these are similar. This is our kind of category, but I don't know the name of the category. Okay. This is the difference between supervised learning and unsupervised learning. Unsupervised learning, you get the features, but not like you have to find the relationship, the similar behavior of the features. You see, for cats, they are similar behavior, the images and all the whatever the properties are, but we don't know the name. When the name is given, then you learn, oh, okay, this group corresponds to cat. Okay, this group corresponds to dogs. Okay. But when these names are not given, this becomes, okay, this is a similar behaving class of animals, or I don't know what it is. It may be a dog. I mean, cats may be dog, dogs may be cat. You don't know the name. Whatever name you give, it's the same thing, right? Does it make sense? Did you understand, guys? So you have to identify different clusters of wine. Which wine compositions are similar behaving? Okay, but you don't know which wine type it is. Or did you understand the difference between supervised learning and supervised learning, guys? Yes or no? Think about the cat and dog example. That's the best idea. Okay, you know the features are behaving together, but you don't know the name. So therefore, no one is teaching you. So you are seeing you're seeing various kind of A written. Okay, let's say you imagine you are a child and you are learning how to write A, B, C, D. You have written your parents are teaching you A, B, A. Let's say. So now the different they have written A different kind of times, 100 times on a piece of paper. Now what you are learning is that you are learning the structure of A. Okay, A has this two straight lines, and your mind is learning that, and this straight line in the middle. You see the similar structure. But you don't say that that's A, verbally. That's A. You don't never say that. If you never say that, that is called unsupervised learning. But if you say that, then, and you ask the student, or then you teach them B, how the B looks like based on all the features. And then you give a new A picture and ask it what it is. That will tell you, oh, that is A. Oh, that is B. But you can never ask this question to unsupervised if you teach the student or the child in an unsupervised way, because the child will not know what is A, right? The child will know that, okay, this kind of pictures look similar. This kind of pictures look similar, but I don't know what is what. They are different, I know absolutely for sure 100%. That's the behavior, but I don't know what it is called. So if you know the names and the correspondings of the features, the behavior and the names, that is called supervised. If you don't know that, just the behavior you know, that is called unsupervised. Okay? Got it, guys? Everyone clear? Fully? Olivia, is it clear with you, all of you? Okay.